So good afternoon, everyone, and welcome to today's webinar on mechanical rigging in Maya. Thank you all for joining us for this another session of CE Experience. Before we begin, I would like to thank our partners whose support makes events like this possible. So thank you very much to Creative Europe Media, Czech Audiovisual Fund, Czech Audiovisual Producers Association, and the Ministry of Culture of Czechia. And it is my pleasure to introduce Daniel Beňovič, who is a 3D animator and technical artist based in Slovakia. Daniel, hi.
Hi, hello,
And
Maroš.
and his experience in animation has transitioned into the gaming industry, where he now focuses on enhancing rigging and animation at the Nine Games studio. Utilizes his skills in Autodesk Maya and scripting, contributes to the game Way of the Hunter, and I guess also to another unannounced project that the studio is currently working on. Just a small reminder, if you have any questions during his webinar or maybe after, there will be a Q&A session, so you can just leave us a comment on Facebook where we stream, and we will try to answer your questions during at the end of the session. So Daniel, thank you very much for being with us today, and the stage is yours.
Thank you. Thank you for the introduction. I'm very excited to be here. Today, I will be talking, as Maroš said, about mechanical rigging, exactly rigging for games. I will just quickly go over how I got here, and then we will go right into the rigging. Okay, so for me, it all started with the computer games. My brother and I used to create custom mods for Grand Theft Auto San Andreas multiplayer, so we could make silly videos with my online friends. I was also editing frag movies from Counter Strike, where I had the first experience with 3D software. As my professional life goes, I worked 10 years in advertising, mostly doing motion graphics in After Effects for big brands like Telecom, Tatra Banka, or Generali. When Blender 2.8 was released, I really got into 3D animation, and I started incorporating 3D into my work. For example, when I was creating opening visuals for the Song of Sieti award event. Then a job came up that combined my love for games with animation and rigging. I had to quickly transition, as Maroš said, my experience from Maya to Blender to Maya, but I went all in, and that's how I landed at Nine Games. And now I am working on Way of the Hunter, which is a realistic hunting game with vast environments, lifelike animals, and highly detailed weapons. It's basically a realistic simulator. And weapons are something that I am working on at Nine Games, as I'm primarily doing rigging and animations for player mechanics. Okay, so let's just really quickly go over what is rigging, so we are on the same page. Rigging is the process of giving life to a static mesh. Without a rig, the animator basically wouldn't be able to move any part of the mesh properly, or it would be very, very inefficient. In the process of creating the rig, we are adding bones, which deforms the object. And we are creating also controllers for these bones, so the object can be animated. And of course, the best rigs are these that make animators' life easy. Okay. So the rig has two main components. it has the rig and the skin. When we are talking about rig, we are talking about few things. We are talking about the mesh, which is a 3D model, or you can say a geometry that you get from your 3D artist. And then we are talking about the export skeleton. This is a hierarchy of bones defining where different parts of the model will bend. This is a skeleton that we will be selecting later for export to the game engine. Also, each skeleton has a root bone, which is at the top of the hierarchy, and it dictates the structure and controls how the other bones in the hierarchy will move relative to each other. Then we have a driver skeleton, or also called system skeleton. This is a secondary skeleton, and it's not used in all rigs. When you are doing something simple like a rifle or shotgun, of course you don't need this. But when you are creating something complex, like creating mechanical patterns, these additional bones would really help you. Also, these bones don't get exported to the engine, so you can tweak it as you need. It's especially useful in complex rigs where separating the driver skeleton keeps everything clean and allows more freedom with additional IK handles, locators, curves, clusters, etc. And this skeleton drives the skinning skeleton, hence the name. Then we have controllers. They are just basically Animator's interface, allowing him easy control over bone positioning, rotation, and other properties. In mechanical rigs, like for weapons, they might function for string tension or pulley movement. Also, same as a system skeleton, we only see them in our animation software as they don't get exported to the game engine. Okay. As I said, every rig needs a skin. This is the data that gets exported to the engine with the skinning skeleton, and basically tells us how the mesh will deform. Skinning is also called weight painting. It is the process where we are basically painting how bones influence the mesh. When you paint something pure white, it has 100% influence. And if you paint the part of the mesh black, it would have 0% influence. And it would not move when moving the bone. When you are doing mechanical rigging, you are mostly doing a very sharp skinning. You are filling the segments of mesh with black or white. But when you are doing organic rigs like humanoids or animals, you are mostly definitely going to smooth out or blend weights between influences. Because you need smooth deformations in the rig that I'm talking about today, we are going to use both techniques, both uh, sharp skinning and organic skinning. Okay. So my task was to create a complex rig for bows and crossbow for our game that allows everything to move and stretch realistically while also being easily adjustable. Also, it had to be automated because we are making multiple bows and crossbow. And completely honest, at the time, this was not something that I would normally do. I was more of a 3D generalist, or animator in that sense, but I really like the challenges, and this was the perfect opportunity. So fast forward to today, and everything is working properly in game. Also, as I said before, rigging for games is a bit different than rigging for movies, and comes with a bit more technical difficulties. As you can imagine, the rigged model for games can be cheated with camera tricks from other angles. To it be game ready, it has to look good from every angle while still being clean and optimized. That means that the number of bones has to be small for the best performance, and also you don't want to really simulate something like this because you wanna full control over how the simulation plays out in the game all the time. And you also need to think of it as a rig for an animation system. It's not one rig. Because the rig will be used for hundreds of animations in multiple scenarios, like standing, crouching, lying prone, mounted, or while reloading, while aiming, and all of that combined. So a lot of animations, and you have to have this in mind, like in pre-production. It's not just for one shot and one animation. Okay. In our pipeline, it essentially means creating such rig requires us to break it down into multiple phases. The first is pre-production, which is the most crucial phase. If something goes wrong at the beginning and we discover it only at the end, the entire rig may need to be redone, wasting precious weeks of work. Therefore, we must do really detailed research and test the techniques for the specific rig. Since everything must be optimized to work well in the game, it can't have too many bones, yet it needs enough bones to look good. We also need to ensure that these processes can be scripted and automated. The second phase is when we are confident in the system and we are going to use for the rig, and we've completed a few successful tests, and we know what works in Unreal and what doesn't, so we can script the necessary steps. The third and fourth phases are just finalization steps. We are making controllers for animators, or for me, to keep everything nice and tidy, and organizing and exporting a functioning rig. Okay, so what did I need to solve? I had to research everything that needs to be animated for the bow. Then I had to create the export skeleton, which is, as I said, a hierarchy containing everything the animator needs to animate. Then I had to create the bones for the strings and cables, but we need to position them precisely on the vertices. So the bones bends nicely to create a smooth deformation effects for the string in the pulley. Then we need to automate this process with Python script to avoid the tedious creation of hundreds of bones when making other bows. Then I had to design a system skeleton or a driver skeleton that moves all these bones in the pulley and functions procedurally, allowing us to only replace the curves when producing other bows. I also had to automatically orient the bones in the skeleton to avoid manual adjustments and ensure that everything's aligned well with these curves. Then I make sure that the skinning process later of the strings can be just easily done with a few clicks in the future, and that I don't have to skin hundreds and hundreds of bones manually. And although the animation will be baked in the end, we want a simple type of the deformation to keep it lightweight in Maya. So no mesh networks simulation, and it also must work in Unreal in the first place. Okay, and that's a lot of things to problem solve. So, what to do? Just panic. No, no, no. Just thinking about rigging something like this for the first time might give you a cold sweat. It certainly did for me. When you are rigging something like this, you have to accept that you are going to learn as you go. It's like R&D process, because there are a lot of techniques in rigging, especially in complex rigging. It's just constant problem solving. You will solve one problem of creating bones, then you will create your perfect driver setup. But when skinned, everything goes wild, and then you have to solve the root of the problem. Then you fix the root problem, another appears, and so on. But in the end, when everything is working properly, that feeling is great. It's absolutely uh, indescribable. uh, as Also, I would take this opportunity to thank to my colleague Peter Scala, with whom I had a lot of discussions about what I could try next when I was stuck. And just to reassure you, it is normal to get stuck when rigging. Rigging process is ultimately swimming in unknown waters, and you need as much help as you can get. So no worries. Also, AI is a great help in this regard. Of course, you know your ways and tricks to solve these problems if you are experienced rigger. But if you are not, just like I wasn't, then AI can really assist you with the pre-production phase, and even the production phase, like it did for me. So, quick disclaimer. When we are talking about I really want to say that I'm not that big into AI systems that replicate or mimic someone else's work. Like, uh, I don't support AI that is stealing the designs of other fellow artists. Instead, I use AI in my pipeline as a chatbot or the tool, this practical tool, and help me automate repetitive or time consuming tasks. So it helps me with research, freeing me to focus on the rig as a whole. And to be absolutely honest, AI isn't any magic word that will fix problems for you. It may even create some more problems for you to debug. When you are working with AI, you constantly have to hold its hand to navigate it towards the solution that works for you and that you want. In my experience, you can find that information also elsewhere, like in books, forums, on Reddit, on YouTube, etc. But you can also use AI to get that information faster and expect to do some debugging. Either way, use what works best for you. So, how I used ChatGPT in pre-production, I asked ChatGPT how the specific mechanics of compound bow works and what part it has, because we need to know it in advance which parts will move and how these parts will interact with each other. Nowadays, we also have the immense advantage compared to the game making era of decades ago. We can easily find reference videos on YouTube and how things work, like motors, pistons, pulleys, and cam systems. And I definitely utilize this. I always save all relevant videos in bookmarks or a YouTube playlist, so I can uh, refer back to them if I need. I also asked ChatGPT how it would go about rigging such a rig, debating most optimal methods and obstacles. It was very useful to just ask for the list of techniques, watch these techniques and examples of them on YouTube, and then just simply compare them. So I used both tools and I can decide on my own. I was first debating if I should use Spline IK, but thanks to ChatGPT, I discovered that it wouldn't be powerful enough. Uh, so then I moved towards locators and clusters, and then creating my own spline system. Then I would let ChatGPT to create me a Python snippet for locators along that spline, and it also helped me to discover how I could do mathematical relationships between them. Then I used ChatGPT to give me detailed info about curves and their possibilities. And then I asked about certain nodes that I could use with those curves and how I can script this so I can change attributes easily in the future. But yes, you always have to give it your exact uh, vision and hold its hand and just debug around it. No. Okay. We are getting to the nitty gritty. I will give you a quick demonstration how I did things in production. So let's start with the skinning skeleton. As I said, the skinning skeleton, the top is the root and everything is below it. Lines continue to the string center. Under the string center, it branches out to the string top and to the string bottom. which are the bones generated by the script for the string. There are like 40 bones for each string for the top and the bottom. And all these bones are generated, which is basically creating them from the spline series. Under the string top, we also have the peep sight, which is that little thing then you can scope through when you are aiming down side with the bow. I knew I had to create the peep side bone because when we are doing some first person animations, we are centering the peep sight in the middle of the screen. So this is why it's good to consult the rig with the animator. But I had the advantage because I'm the animator myself. Okay, so let's move to the cables. They are same as the string. They are also created by a Python script, and there are also like 40 bones each of the cable top and bottom. Then we have a bone for a rail, and the rail bone is just for a scope, so we can later attach a scope to the rail bone. Then we have the limbs. Limbs are these things that are bending. There are they are the part that is connected to the pulley mechanism. We have a limb top and also a limb bottom. There are four bones each, and under the limbs there is a pulley. Pulley bones have these pins under them, and they are connected to the cables. So basically, when you are moving the limbs, you are also moving the pulley, and then you are moving the pins with it. Then we have a slider, which is this little thing that cables go through, and we have a bone for these things also, so we can animate the movement. Then there's also ammo. This is a socket for the arrow. And then we have the rest, which is basically a rest position for the arrow. And that's everything. Now we have a complete hierarchy, and the root is always at the top of the hierarchy. While we could manually create bones on specific vertices, since we will need to create over 100 bones for the strings and would have to do this for each new rig, it's best to automate this process. We achieve this by closely collaborating with our 3D artist. The model has edge loops. These are the points where the model bends, and these edge loops need to match one-to-one with the curves we will later use in the rig. Our 3D artist will create a model with the exact number of edge loops on the string, and he will also create a curve with the same exact number of CV points. And I can then write a script that creates a bone at each point of that curve, ensuring that the edge loops and the bones align. We may know, we may not know it yet, but this will ease the next steps, as weight painting the string is basically non-existent. We will have same number of points on the curve that wraps around the mesh, which will also have the same number of edge loops. Skinning will be basically giving 100% weight to each edge loop, and we won't have to skin the string manually, just tweak a few things. I also really like to automate things if it's possible. So as you can see. And Autodesk Maya is the perfect tool for that because it operates on Python, uh, allowing us to script the entire process. Also, what I love about it is that as Blender, it has a ton of tutorials for everything. Maya has a lot of scripting nerds around the internet, and they are solving the same problem as you, just on a different type of rig. Only in Blender, video was added 2 weeks ago, and Maya video was added 13 years ago, and in potato quality probably. But it works, and it can help you. But you get the principle down. I will help you with the rest. Also, these scripts can be also reused when we create a different type of rig, for example, like hair, octopus, or something that does movement through the curves. And how to create the system skeleton or the driver skeleton. This is probably the most crucial and also the most complex part of the rig, as this skeleton drives everything. Hence the name driver skeleton. The skinning skeleton we will be also constrained to it, and I think it would definitely be possible to do it differently, perhaps by the directly using deformers like uh, lattice, curve wrap, or even mesh or Bifrost. But it's really important to do your research and several tests and see what works best for you. You will see what is the most lightweight and easy to work with, and if it also bakes and exports without any problems. We need to select a method that can be modified procedurally in this case. And we tried several options, but we ended up with a combination of curves, clusters, and locators, which works well. Because, for instance, curves can easily be swept out, making it procedural, and clusters and locators can be easily scripted to adapt to everything else. The wrapping system then updates, so the hardest part doesn't have to be redone for the each new bow. And also, thanks God, all these med nodes didn't have to be done manually, because you can script those relationships with Python and ChatGPT. A lot of info, right? Okay, let's continue. To understand this clearly, we need to imagine this system as having three layers. The first layer has a curve representing the pulley on which locators will wind and unwind. These locators will represent the control vertices of the second curve, which will also wind around each other, creating an imaginary curve that wraps in on itself, thus creating a realistic cam system for winding and unwinding. The second layer is the curve made up of locators. This curve winds into itself, but the rest of the curve points are going toward the string center. You can also use AKI for that. It's scripted so that only the number of CVs that match the bones on the pulley will wind into each other, with the remaining CVs pointing towards the string center. Because this way we create a trajectory along which the rig bones can slide on, and only those on the pulley will be locked in. In the script, I also create a density controller in case we need to change the CV density for different bows. The density control is just an attribute from 1 to 10, which can easily be changed. And the entire alignment system adapts. The third layer is just the curve where the bones are generated. And as we said before, these curves must be exact number of CVs, as there are edge loops on the mesh. So it will deform the same way as the second curve, which will have the same number of CVs. But it's need to be aligned in its bind pose. Then we need to address the joint orientations, as aligning bones along the curve can sometimes lead to weird bugs and artifacts. The orientations must be clearly defined right from the alignment process. This entire process is about debugging and figuring out what works and what doesn't. Of course, I automated this process with Python scripts as well, so I wouldn't have to deal with it manually. I determined the orientations needed for our rig and used ChatGPT to create constraints with offsets, which are integrated into the alignment script, so I don't have to do it one by one. And as you can see in the video, the orientations have to be exactly right, or the rig is gonna break. So this is the really important part of the rigging process. But you are asking how to determine the right orientations. For better understanding, you can think of it as a skeleton of a mechanical objects is like skeleton of a human. It has the root that goes up the spine, and branches of the off to the left and the right. In our case, up and down. We can either create an exact table for where everything goes and quickly drive it for ourselves, or we can simply use trial and error methods to test various up vectors and see what works for our rig. Or we can set custom up vectors and try different stuff. Lastly, we need to address skinning, but we have already effectively resolved this in the script when creating bones on the precise vertices. As soon as we use the bind skin function, the bowstring and all the cables will deform as they should, and we don't have to do anything else. The only tedious task left is weight painting the limbs, because that part is the only smooth part in the rig. But you can only do the top limb and mirror the bottom limb. So we have created a pulley system that wraps on itself, rotates, and aligns the mesh on precise vertices with the correct joint orientation, following the trajectory we want. Thus, we have one pulley ready. We just need to replicate it for the other three uh, pulleys, as there are four in this rig. Good thing that we have scripts. We will use the same system for the lower pulley and for the cables as well. So the hardest part is behind us. Now my favorite part: when everything works, we can add nice and colorful controllers for the animator and organize everything to be clear and neat. Each part of the rig has its own controller, which is essentially a shape that is a parent of the bone. This shape is what the animator would use when animating, so you can hide all the bones. And as you can see, when I'm moving the controller, the bones are moving with it. You can create them manually, but I create them using Maya bonus tools, which is a free plugin. And it's best to separate them both by color and by shape. And as a detailed orient person, I also match the colors in the outliner. I use the plugin color marker, which is a free plugin, and I highly recommend it. No, of course, it wouldn't make sense for the animator to move every single controller individually. That would be a nightmare. This is where we get to set up the magic that every animator waits for: set driven keys. I won't go into full tutorial here, but you can find plenty on YouTube. You simply make a keyframe at the start, set all the translations and rotations of all controllers, and then you set the final position, and then you key the final position. You can also do this by expressions, but set driven keys works as well. Since the rig is built to follow the curves, when you rotate the pulley, the string will stretch automatically, so there's no extra work needed. The rig is now ready for the animator, who only needs to move the one string main controller. It's also essential to check the export hierarchy too, which is simple. When you move the root, the entire rig should move with no parts left out of the transformation. Also, make sure that the hierarchy makes sense. For instance, the pip side should be under the string in the hierarchy, and any additional bones, so that when we are moving the string, the pip side moves with it. You will notice quickly if something is off, because moving the root would break something. It's also a good idea to rotate the rig in space or run a quick test animation, as the player may tilt the weapon during gameplay, so everything must work smoothly. The best feeling comes when the rig is finished and ready to export. Select the root of the skinned skeleton and export the whole hierarchy with the skin as FBX. From there, it goes as a skeletal mesh into Unreal. Then we export a test animation from Maya as an FBX2 and open it on the skeletal mesh in Unreal. So here we go, the final product. It, it's a rigged bow. Thank you. That's all. I hope you enjoyed this quick workshop.
All right, Daniel, thank you very much. So we were hoping for a bit of a more technical lecture with you, and I think we got it. This looks
Yeah.
super hard.
Uh,
Actually.
y- yeah, it's somehow it is like you need a lot of time to process all of this and to prepare all the things. It's like R&D
Mhm.
process.
Yeah, so I would also like to remind our audience that now is the time for your questions. So if you have any questions, please don't forget to write them into the chat and we can read them out loud and address them. And meanwhile, I also have a few questions of my own. So connected to the first comment that I had that this looks super hard, I would also like to know how long does it actually take to rig one bow like this?
Oh, the R&D process took longer because you need to address all the issues and problems we're creating. You also had to do automation beforehand. So few weeks it took like something like a month, I think. But once you have the rig ready and you know that it will simplify the process of the next rigs, then the next rig can be done in 1 week, and it will like save time when you are doing like 10 bows in the future. So basically, you are saving time later.
Mhm. And so we have a first questions from the audience that also ties to one of my questions that I have written over here to ask you.
Mhm.
So the question is for 3D, what is better, Blender or Maya? And the follow-up question for me would be why actually has your studio decided to use Maya instead of Blender? Since I have a feeling that nowadays a lot of people are actually transitioning to Blender, so it's free, it's super robust, it's like an industry standard. Uh, which is not to say that Maya wasn't for I don't know almost decades now.
Yes.
Yeah. So, but if you would compare them and what are the pros and cons and why one is better than the other?
Yes. So for me personally, I enjoy both. I think that there is no better package. Like Blender is not better and Maya is not better than Blender. They are basically both very powerful in their own. I prefer Maya for rigging because of the Python capabilities and customizability and scripting aspect. And we choose it because of the animation layers of Maya as well. But I think that Blender is also now getting the animation layers. So a very exciting time for Blender users. I started out in Blender and I really love Blender community. I'm also all the time searching what are the next thing that the Blender is planning, and it really is catching up to the Maya animation standards. So there is not an exact answer which is good or better. It's just what your studio uses, because when I got to the Nine Rocks, we were using Maya. I was using Blender in my personal projects, and I just relearned to Maya rigging like in few months, and I adopted the Maya workflow. So
So ideally, you should know both.
yes, I mean Blender is very strong in modeling and in motion graphics now. Geometry nodes are great, uh, like any freelancer's dream, and also it's free. So Blender is great. So if your studio approves it, go for it. But we had a workflow pipeline in Maya, so we use Maya.
Right. And we have some more questions coming from the audience. Another one is, can you advise us on some rigging plugins for Maya that you use? I was just doing basic rigging with advanced skeleton and it worked quite well.
Mm-hmm. Yes. For skinning, I would suggest NG skin tools, but that's like when you uh, get around the basic Maya native skinning, then you can expand to NG skin tools. That is like essential for me. Then also, like I said, there are a ton of plugins and scripts for creating controllers. That is a nice time saver. I think it's called color marker and control creation. I don't remember exactly. For animation, we absolutely use Studio Library when you can save all the poses. That's a must have, because when you are doing a lot of poses for first person and third person, then of course you need to save the poses. And for the rigging, there are ton of scripts like through the internet. I don't remember from my head, but I just search GitHub for creating constraints and joints and automatic things like also rigging with advanced skeleton. Yes, it could be great. I also use the M-Gear framework for rigging, but each rig is different. Like advanced skeleton is nice for characters, and when you are creating some chain rigs or something mechanical, you can also look into M-Gear.
Another question is, do you have any recommendations for in-depth courses about prop rigging? Something a bit more advanced, maybe.
Oh, okay. I would absolutely recommend YouTube tutorials from Anthony Ward and CGI. He has great tutorials in depth all around rigging, be it characters, but also some mechanical rigging, and lots of YouTube and random tutorials. I don't remember from the top of my head.
And another question: Can you tell us more? Can you tell us more about when you create characters for the game, how you implement them into the game? And there's a follow-up question: How complete is the game? Maybe that you are currently working
or
on. I don't know. There's a
how to complete the game, or
could be both.
Yeah. So there is a lot of people involved in creating a game. I'm just a small uh, part of the equation,
How many
like
people
the
work in your studio?
like 50, 60,
Hmm.
I think. Actually, yeah. Actually, it's 50, 60. And there is a lot of planning, designing. First, you need to design everything. Then there are 3D artists which are giving you the 3D models. We are rigging the models. Then we are animating, and there it goes also quality testing, bug fixing. It's a whole thing is just uh, it's a lot of work to do. You can't simplify the process. Where if you are solo game developer, of course, but I have experience only working in larger studio, so lot of designing and teamwork. But it's great at Nine Rocks. I uh, really like our system, and everyone here knows what he's doing.
Hmm. So, and maybe the last question from me, if there are no other questions from the audience. So, obviously, this C animation, our organization is mainly focused on animators and on animated film primarily.
Mhm.
You're nowadays you're primarily focusing on digital games and
Mhm.
game development, but still is some sort of overlap. So, my question would be: could you maybe walk us through your career journey from animation to the gaming industry, and what is different and what remains the same when you compare these two industries from the technical artist and animator point of view?
Yeah. Uh, I was a 3D generalist. I was doing a lot of graphics work and videos for uh, ads, and there is a lot of timelines that had to be like deadlines that can't be pushed, and you have to go around making something quickly. So you can when modeling and rigging for ads, you can sometimes um, hide a lot of things in the shots. But when you are making rigs and animations for games, you can't really hide anything, because it can be looked from every angle, and you really need to spend the time on the process. So even ri- uh, 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 the rigging and animation process is more detailed, and you have more time for it also allocated. So I think that the time thing is really, really the key.
All right, Daniel. So, thank you very much. And we are very much also looking forward to your next game release, which hopefully will be very soon, maybe this year or next year, if you can say. If you
I
don't,
can't.
you can, because there's an NDA, right? But still, we are looking very much forward to what you will manage to build. Probably based also on some technologies that you already developed with the Way of the Hunter game, which people can actually play right now. Right, it's
Yeah,
available
yeah,
on consoles and also on Steam. They
yes,
can also check out your work in the game. Maybe try some of the crossbows. And yeah,
yes, of
once again,
course.
thank you, Daniel, very much for being with us, and looking forward to another CE experience. Hopefully, within a few weeks, we'll have another lecture or a webinar ready for you.
Thank you for having me. Thank
Thank
you.
you, and see you soon.